Today I'm going to be explaining a question that a lot of people have, and the answer really isn't quite so obvious. And it's, why is the sky blue? Okay? So, yeah, why is the sky blue? Okay? So, first you got to look at what kind of light is coming from the sun, because that's 99.9% of the light we get here on Earth is coming from the sun. That's the light that lights up our sky in the day. So you look at this, and you see that this light is actually mostly centered in the green end of the spectrum. So if you look at a plot right here, or right here, I'm not sure where I'm going to put it, you're going to see that it's actually got sort of spikes up into the blue-green end and then sort of peters out down into the red end. So it's actually putting out a lot of green light. Well, that doesn't help us. That seems to say that the sky is green. It's not green, right? There's not much blue. So what happens here is something called Rayleigh scattering happens in our sky. And so tiny particles in the sky, these little particulates, will actually scatter light. So the light will come in and actually bounce off these little particles. And so what happens when the light bounces off the particles is its frequency gets shifted, just like when light bounces off my shirt, my red shirt here. The frequency of the light it blocks all the frequencies except red, which is why it shows up red. And so what happens in the sky is that these particles will do the opposite, essentially, and so they'll scatter all the blue light. So if you got the Earth here as my hand, and you have the sun here, the light's going to come out from the sun, and then it's going to pass through the atmosphere right above the Earth, and all the light is actually going to scatter. The blue light is going to scatter straight down, more or less. I mean, not exactly straight like a laser, which is going to be the topic of our next video, but it's going to scatter down towards the ground, which is why the sky appears blue in the day. And then, well, that's not exactly true, because it scatters the shorter wavelengths, but we'll get into that later. So it's going to scatter the shorter wavelengths down as it passes through, which is why during the day it appears as blue. And then by the time it gets to sunset, you're sort of on the edge, and the light's already, all the high-frequency light has already been scattered, which is why sunsets appear to be deep shades of red and orange and yellow, because there's no blue and purple light left, and to some extent green light, to make those, to overpower those colors. And so that's why the sunsets are typically red and the sky is blue. But if I said it scatters higher frequencies, if you look, purple is a higher frequency than blue, so that doesn't make any sense. Well, that has to do with what we said first, the output frequency of the sun, and also the sky. Not the output frequency of the sky, but the passivity of the sky. So the sun, you'll notice, doesn't output so much purple light to even get scattered in the first place. It outputs a lot of green and blue light, more or less, to get scattered, but not so much purple light. So there's not that much light there to begin with to even be scattered. But there's more problems with purple light. Turns out our sky doesn't really like this. It's not as clear, if you will, to purple light as it is to blue, green, and red light. So that's why ultraviolet light is mostly attenuated in the sky. That's why you don't get a sunburn immediately when you step outside, because those super high frequencies of light get attenuated by the sky pretty well. And so the purple is also a fairly high frequency of light, and it gets attenuated by the sky. So in fact, the purple light that does scatter, there's not much purple light to scatter in the first place, because the sun doesn't put out so much. And then, in the second place, what purple light does get scattered gets absorbed by the sky. It's not clear, if you will. So, and then there's a third problem, which is your eyes. People are really actually bad at seeing the color purple. It really has to be that if the main output of an object is in the purple spectrum, so in other words, it sort of starts winding up in ultraviolet, peaks in the violet or the purple spectrum, and then drops down to blue and is nothing at red, it's actually going to look blue to you, because there's a lot of purple light, you're not very good at seeing the purple light. There's almost as much blue light, not quite as much, but almost as much, and you're really good at seeing blue light. In fact, the frequency you can see best is green, which is right next to blue. So you're not as good at seeing blue as green, but you're still fairly good. And so what you're going to do is you're going to actually see that object as blue, because your eyes are saying, that's a lot of purple, but I'm not really good at seeing purple, so it doesn't see all that purple so well, but it sees a lot of blue, so it's like, that's blue. So for an object to look purple to you, it actually really has to be dominantly purple. So its main output is probably going to be in the UV. Either that or it's a laser and it actually has no other output frequency. And even then, because people are bad at seeing purple, if you take a purple laser, it's going to look like a different color to everyone else. A lot of purple lasers will look blue to people, and in fact to this camera that I'm filming on right now, purple lasers actually look blue. And so that's the reason why the sky is blue, and that's the reason why the sunsets are red. Hope you enjoyed watching.